Hello everybody. Welcome to today's panel discussion. Very excited to be with you all today. We have very special guests with us. I'm going to start with Dr. Misra, Dr. John Hedengren, Dr. Elbanbi, and we're going to go over some really deep discussions about the applications of machine learning, especially in the oil and gas industry. But before we do that, how about we just start with Dr. Misra and just if you can introduce yourself, tell us about your background, and then we'll just go around and do a quick introduction.
Okay, thanks a lot, Haas. I think you can hear me fine.
Yes, sir.
Perfect. So I'm an associate professor in Texas A&M University. I've been here for the last 2.5 years. I focus a lot on petroleum data analytics, machine learning. I teach formation evaluation as well. And one thing that I'm really excited about here is I'll be interacting with a lot of students. That's what they are here to learn from. So I think data science has a lot of potential. And hopefully I'll encourage some of you to kind of dedicate your career ahead to data science. So with that, I'm glad for this particular opportunity.
Great. Thank you so much. Dr. Hedengren.
All right, thank you. And Oscar, you do a great job organizing these things. Glad to be on another one of the panels. You do a great job with that. So I went to UT Austin for grad studies and then worked in industry at ExxonMobil for about 7 years. And I've been at Brigham University now as an associate professor for 10 years. And I work on energy systems, especially optimization, machine learning, data science. I also do unmanned aircraft systems as well. So I've worked in drilling, downstream refining, UAVs, and polymers. So I've seen quite a few different industries. Glad to be able to join this panel discussion and to contribute, but also learn from what's said today.
Thank you so much, Dr. Hedengren and Dr. Elbanbi.
All right. Good morning, good afternoon, and good evening, depending on where you are. My name is Ahmed Elbanbi. I'm professor of petroleum engineering and the chair of the petroleum engineering department at the AUC, the American University in Cairo. My career was probably two halves, half in the industry doing reservoir engineering and reservoir simulation and field development plans. Most of the time I was working for Schlumberger, 5 countries in 5 different countries. And the other half is academia, where I did the assistant professor, associate professor, and finally professor. My areas of expertise are mostly reservoir engineering, and in the past few years we do a lot of graduate work on data analytics and artificial intelligence. Thank you, Ross.
Awesome. Thank you so much. And I'll do a quick introduction about myself, and then we'll get right into the questions. So my name is Belyadi. I started my career about 12 years ago. I was a completions engineer, got a lot of great field experience. You know, after a couple of years as a completions engineer, I did about 5 more years of reservoir engineering. I was involved in all kinds of reservoir modeling and they can name. And in the past 5 years, I've switched over to the data science, particularly the applications of machine learning in the oil and gas industry. My primary roles have been optimizing drilling, completions, and production. And in the meantime, I've also taught at different universities, at WVU, West Virginia University, Marietta College, and San Francisco University. And I'm very excited to be with you guys today. We have a list of questions that I was going to go through today. So I'm going to start off with the first question, and that is, what is your overall vision for machine learning applications in the oil and gas industry? And by that, I mean, where do you see the trends heading? How will it revolutionize the industry? If you guys can provide some examples, that would be appreciated. And we can just, again, start with Dr. Misra and go around the table to get everybody's feedback. I believe you're muted.
Okay, so can you hear me now? Perfect.
Yes, sir. Yep.
So machine learning, where can we use machine learning? So I have a very simple explanation, and the way I follow is 4 steps. The first thing I ask myself is, does this problem have a rule-based approach, or does it have some kind of algorithm that you can design? If not, then those kind of problems are suited for machine learning. The system that you're trying to understand should be complex, it should be heterogeneous, it should have some emergent and hidden properties. And the word emergent and hidden, they're not simple English words. Those of you who are listening to it, do a little bit of deep study into those words: emergent behavior, hidden behavior. If your system has these properties, then machine learning is best suited. One problem that I see in a lot of machine learning applications is they apply machine learning on a very simple data set, which is not multimodal in nature. So what I mean by multimodal is the way I talk to you. I use my hands, I use my voice, I lower and the way I talk to you, I use facial expressions. This is multimodal communication. So any system where you have sensors that are studying different physics, then that kind of system will become multimodal. So you have data coming from these multimodal sources. If your data is coming at a large volume, at a very high rate, and if your data is unstructured, that kind of problem becomes suited for machine learning. So in oil and gas, I see 4 common uses of machine learning. The first one is if you want to automate mundane, repetitive, low-risk tasks. Anything that's boring, if you want to automate it, machine learning helps a lot. The next is if you want to build a system or if you want to build a model that evolves with time, machine learning is best suited for that. For example, there's a reservoir model. You are measuring pressure, you're measuring rate, and you want to build a model that evolves with time, then machine learning can do it for you. If you want to detect minute patterns, very small signatures, things, how a data is similar, how a data is dissimilar in a very high dimensional data set, then machine learning is very important for that kind of things. And one final thing is if you want to do precision engineering, machine learning again shines. So for me, these are the 4 areas where a lot of oil and gas applications has gone into.
Got it. Got it. Thank you so much. And Dr. Hedengren?
Yeah, thank you. And, I totally agree with that assessment, and where it's applicable. That's a great overview. One of the things that I saw just on a recent distinguished lecture tour, I was a DL for SPE and traveled to many countries as part of this tour, talking about machine learning in the oil and gas industry. And it was interesting. One place that I went to said, "Hey, none of this is applicable to us because we're just not collecting data." And they just emphasize like, hey, the data availability is not there right now. We need these foundational things. And as I've worked in this area more and more, I've seen companies pivot more toward the data engineering side. How do we collect data, cleanse the data, give this foundation for those that want to implement algorithms? And Haas, if it's okay, I'll just share my screen really quick.
Yeah, absolutely.
And I have just one or two slides here. Let's see. Does it show the presentation there?
Yes, sir. Yep.
Okay, let me swap the. Okay, and one of the things that we've seen is just so many application areas that have been dramatically affected by machine learning and data science. And you see some of those on the right there. And it's really due to this increase in data availability, the advances in computing hardware, and the improvement to optimizers. So we look at things like, self-driving cars that have been enabled with computer vision and algorithms. You look at things like, wind farms, jet engines, and others. You have just this huge amount of data that's available. So how do we harvest that? How do we use that? But I think it gets back to that, foundational point. How do we cleanse the data? We have so much available now. How do we turn it into actionable information that can be used productively? And I think that's the big part of the challenge right now is what do we do with that flood of information?
Yeah. Thank you, John. I definitely agree with you on that. That I think a major push has been going from hiring data scientists to hiring data engineers, especially in the past couple of years, because I think people have hired a lot of data scientists, realizing they don't have the data even like gathered yet. I think a major push has happened in the past couple of years of even like focusing more on data engineering and getting all that data set up prior to going into the data science aspect of it. And so thank you for alluding to that. And Dr. Elbanbi, can you please provide your feedback on this question as well?
Okay. The question is, where are the trends of data science in oil and gas applications? The easy answer to this is everywhere. And I'm going to say something, and I shouldn't have been on this panel after I say it, or I shouldn't be on this panel after I say it. Again, the data science is like, it's a trendy thing. We have seen before in our industry several trendy things, like, for example, 3D seismic. When it came out, a lot of people thought it was going to be the solution for everything, and yet it is not the solution for everything, and we keep adding technologies. When 3D modeling, for example, came out, we said 3D modeling will be great, the greatest technology ever. When geostatistics came out, we said the geostatistics takes care of the heterogeneity, etc., etc. So now we are in the hype of data science. Definitely the data science has applications in every subdomain of the oil and gas industry. It will help us analyze the huge amount of data that we collect. It will help us automate a lot of our analyses and a lot of our operations as well. We can think of robots drilling our wells to a certain degree. So data science will help us definitely with that. So for the trends, the easy answer is in every subdomain of our industry. But having said that, I still think we have to produce very strong petroleum engineers with a lot of fundamentals, because these are the ones who will be able to apply the data science to solve our problems. Okay. Thank you.
Yeah. Thank you. And I'm gonna just provide a couple of comments too here on this question. So just being in the industry for the past like 12 years now, one thing that I've noticed, at least in the past few years, the application of machine learning, it could be applied to different areas, as Dr. Bemby just alluded to, drilling, completions, production, even safety, So one of the areas that I see a huge application in, so a lot of the projects that have been done in the past have focused on a lot of static models where you build a model and you basically find hidden pattern from the data, which is great, which is very important, right? Especially as these data sets get larger and larger, it is very hard for human to decipher that information, right? But one area that I think the industry, especially the E&P companies, have been pushing more and more in the past few years have been a real-time decision making. Like, for example, let me give a couple examples on the safety front. It's almost impossible to monitor every single person on site to see whether they have their PPEs. They have their safety glasses, hard hats, stuff like that. So that's where the application of deep learning comes in with convolutional neural network to find those objects, real time on site and flag those people that are not wearing their safety devices. So that's one application. Another application is coupling, using cloud or edge computing, again, to make real time decisions, especially with the edge computing. So in the past, let's just say on a drilling site, one of the most important areas in drilling is to optimize rate of penetration while drilling a well. So what can I do to connect, an edge device, which is a mini computer designed for harsh environment, and deploy all these scripts, Python or whatever programming language you use on the edge device and make real-time decisions. That's one area that I see a huge potential in. Even on like production, what can I do to deploy these edge devices and make real-time decisions on the production front? On the completions front, we have people that are, like company men on site that, call frac stages, which means they say, okay, well, let's increase rate, let's decrease rate, let's increase the FR concentration, let's do this and let's do that. All of this right now is being done pretty manually, so I think over time we can develop some models to automate this entire process of rule-based process decision-making that can all be done with algorithms. Now, I think we're going to see a lot of pushbacks from, we can't trust the model yet and stuff like that, which is true, no model is 100% accurate. It's going to take time to get to that level. But I think once we build more confidence and kind of build that liaison, it's going to get better and better. So I do see a lot of potentials in different areas, especially with deep learning to make real-time decisions. And I think that's where a lot of the E&P companies are actually heading to. So with that, I'm going to go to the next question now. Which areas, I guess, in the industry, do you guys foresee the biggest advantages in using machine learning to solve complex problems? If you guys can provide maybe some examples with their value proposition, that would be appreciated. We can start again with Dr. Misra. I think you're muted again. There we go.
Yeah, as I mentioned earlier, that any field that generates a lot of data, or any field that has a lot of different types of sensors that is measuring different physics, which is generating unstructured data that is coming to you at a very high rate, which leads to a pretty large volume of data, that industry is the one that we should look for, or that discipline is the one that we should look for in terms of using machine learning or data science. So from that point of view, there are some advantages in the geophysics world, the seismic world, but it's relatively more static than the production side of the world, which is more dynamic, but they don't have a lot of different sensors that is generating a lot of unstructured data. So yeah, both the seismic and the production side, they have benefited a lot from machine learning, but truly speaking, none of them have all the requirements that make them very well suited for machine learning. So I've seen a lot of applications in the seismic world, and to the best of my knowledge, in the seismic side of things or geophysics side of things, the main focus is how can we make things faster? How can we remove the human from the loop so that the human can think about the big picture, make better decisions, rather than doing the same mundane repetitive tasks? That's what I've seen in the geophysics. On the production side of things, we need models that help us in real world decision making, real-time decision making, which helps us evolve the model with time. So it's a very different philosophy altogether on the production side. And one final thing, what I've seen interacting with a lot of clients, a lot of oil and gas companies, is they want to tie this machine learning with the revenue, with the cost, with the profits. They just don't want machine learning for the sake of doing a very small task. They would rather try to connect all these links that then tells them what's the right revenue strategy or what's the right way of generating profit and so on. So that's my kind of understanding. A lot of people are trying to build drilling systems, automated drilling systems. To me, it seems really challenging, but some teams have made a lot of progress in the drilling side of things. So that's my perspective.
Yeah. Thank you. Dr. Hedengren?
Yeah, thank you. I'm going to share my screen again. Let's see if I can do that. So I work in the drilling area in particular, and one of the things that we've seen recently with machine learning is in the area of automation. It's a very complex situation to drill a well, and so many different phases where you're they call it saccadic, where you're stopping and starting, and you have to make decisions at every point along the way. And one of the things they've seen with recent successes is, greater accuracy and consistency, faster drilling, fewer interruptions, more accurate directional drilling in particular. But there's even more than that with the economics. There's kind of the health, safety, and environmental factors. A recent assessment is that there still continue to be uncontrolled well situations, for example, in the Gulf of Mexico each year, even after the Macondo incident. And so, clearly there are some issues that are economic, but are also health, safety, and environmental that give you that continued license to operate. And as we think about a particular case studies, there are many in the literature. They're reported now that we can drill faster using some of these machine learning models. We understand what is the right combination of weight on bit and RPM, for example. We did a study with a company a couple of years back, looking at even further ways to tie that in and to use machine learning to understand the effects of other things as well. Like, when you're drilling, you primarily use rate of penetration and weight on bit to control, weight on bit and RPM to control rate of penetration. But we use some machine learning models and together with simulators, detailed simulators that could be able to track and help us train the machine learning in real time. As you mentioned, Haas, these models are very detailed, and how can we use some of the information from these models to train machine learning in addition to the data? And so we trained it on these with these detailed models, and we gave it to the optimizers to say, well, okay, you figure out how to drill. And it did something very surprising that we didn't anticipate. We gave it a large gas influx to simulate, what would happen with this automation scheme if you got a large gas influx, what would it do for well control? And it did something surprising. It increased the RPM of the drill string. In addition to, in managed pressure drilling, you close the chokes, increase the recirculation. But it increased the RPM, and we're like, that isn't right. You would never increase the RPM of the drill string if you have a kick. And so we talked to people about it, said, hey, this is what it came up with. We don't think it's right, but what do you think? And they said, actually, that's right. But it's not what we do currently. But if you increase the rotation rate of the drill string, you get an immediate and a long string increase in the friction factor of the fluid coming back. And so it had been able to figure out that effect that we previously did not anticipate as a well control measure. And so it was kind of a nice way to see, okay, we're giving all of this data to these algorithms, and it was able to figure a new way of operating, a new way of responding to gas influx. So that's just one example. But the other thing that it did was just kind of surprising. During that large gas influx, it was able to control the gas influx. And then it also understood that as you decrease the pressure, you also increase the rate of penetration. So it decreased the pressure to the pore pressure. And so in addition to controlling the influx, it was able to increase ROP. So it did a couple things that were surprising to us. I think that's part of the excitement of the machine learning. Is it going to be able to change the way we do things? Is it going to fundamentally change the way we drill? We look for these look for oil and gas. Is it going to fundamentally change the way we do business? And so in this little instance, we did see some effect there.
No, very, very good example. Yeah, thank you. Thank you for sharing that. And Dr. Elbanbi, can you also provide your feedback?
Okay. The literature actually has so many different applications of machine learning in modeling, like in dynamic modeling, for example, to replace simulators. I don't want to say to replace, but to augment the information that we can get from simulators, numerical simulators that everybody's familiar with. Several applications on many other things. Let me talk a little bit about what I do in academia. We're fortunate, I think, that we work with a lot of bright graduate students, and I've been working with some of them in the past years. So we did several applications. For example, from the pressure derivative, we can identify the model, the best model for modeling the build-up or the drawdown test. There are applications also in optimizing pump performance, although I'm a reservoir engineer, not actually into production much. We did another application to optimize the rate of penetration. Again, I'm not in drilling, but we approached it from the data analytics point of view. So the potential is huge. Any time we are dealing with real-time data, I really think there is potential for finding a good application for data science and data analytics. Let me make a comparison with Excel, for example. The way we can find more applications and more efficient applications is as follows. Remember, when you're learning Excel in the beginning, you're happy to do few plots, and after learning how to make some plots, you find applications for what you learn. Then you go to another level. You can write formulas in Excel, and then the applications that you can do with Excel increase significantly. So my proposal here is that for everyone who's participating in from the students, if you don't know much about machine learning and artificial intelligence, start by learning a little bit about it and increase your knowledge in that domain. You will find the application. So if you can combine the machine learning or the data analytics, and I don't bother myself with the different definitions of the different terminologies and all of that, but you know what we're talking about, artificial intelligence in general. So if you learn about it and you have the domain knowledge, which is the petroleum engineering, you will find plenty of applications. All what it takes is you sit down, drink your coffee, sit down for a couple of hours, concentrate, and you will find lots of applications to work on. And they will be useful applications.
Yeah, thank you so much, Dr. Elbanbi. And I'd like to also add just a few comments on this question. As I mentioned before, you have applications in drilling, completions, production, midstream, in terms of using machine learning to solve problems, right? I think every company is different, right? So my advice to everybody that's going to work for the industry is to just see what kind of problems any company has, what they're trying to solve, or and also see what kind of data they have. See, let's just say if you're trying to solve a complex problem, a complex drilling problem, do they have the data? Is the data coming in or not? So depending on what type of data they have, and also what kind of problems they have. I think the biggest thing when it comes to using machine learning is kind of its value proposition. Just look at what is the value proposition of, for example, doing this project in terms of, okay, here's if I do this, if I find this pattern or hidden pattern in the data, how much money can this analysis add to the company? I think the biggest issues that we've had in the past has been we're not focusing enough on value proposition, and that has put a lot of the executives in a bad position. Oh, do I really want to spend the money on this or that? But we can't really truly define the value proposition. So two things: one is to focus on what kind of data we currently have, and then two is which areas do we have the most problems in, so we can focus on those areas. And And all of these issues, I think, goes back to your domain expertise, right? If you're, for example, a drilling engineer or a production engineer or completions engineer, you understand that domain better than anybody else, right? So you understand every aspect about drilling, or let's just say most aspects, let's just be humble here, about drilling operations. If you're a completions engineer, you understand most aspects about completions, So focus on problems in your domain that you understand very well, and then try to tackle those problems. The entire machine learning, lies in three different, aspects. One, you have the supervised learning, you have the unsupervised, and you have the reinforcement learning. These are the main three types of machine learning, right? And so the next step, once you have the data, once you know what kind of data you have, once you know what kind of problem you're trying to solve, the next step is trying to find, which type you're going to use. Are you going to solve the problem using a supervised, unsupervised, or reinforcement learning? And that goes back again to the type of problem that you have at hand. So, and also that goes back to the objective function. What is the objective function of this problem? If your objective function is, for example, like production optimization, supervised is very powerful. You can use the supervised learning when you have your inputs and output and tie those together and take it to the next level, right? If your objective function is, for example, just clustering your data, then that's when the unsupervised learning comes in, right? If your objective is, finding a more of a real time, more of a ongoing solution to your problem, that's when the reinforcement learning comes in. So it really depends on what you're trying to accomplish. But I think if you focus on the data itself first, and then focus on the type of problem that you're trying to solve, and then see what kind of model would you want to use, and then tackle that based on your domain expertise. That's some of the applications that you can apply to, and it can be applied to honestly any area. It could be drilling, completions, workover. It could be just a simple problem that you just have a lot of data that nobody has been able to solve. So these are my comments on this question. And finally, our last question for today is, it'd be unfair to not ask this question, is what are some of the challenges associated with using machine learning? I'm sure every one of you have faced challenges in the past, and what do we do to kind of overcome those challenges? Maybe if you can provide an example, that would be great. And we can again start with Dr. Misra and go around.
Okay. In terms of challenges, there are many challenges from my perspective. As in, just if we start with the beginning, the entire industry, oil and gas industry, did regression, classification, clustering since 50, 60 years now, or maybe at least 30, 40 years. But all of a sudden, for the last 4, 5 years, everybody started using the word machine learning, but all they are doing is the simple regression, classification, and clustering. So one big challenge that I see is we are not applying machine learning the way it should be. And as I already mentioned so many times, your data needs to be unstructured, large volume, coming at you at a high rate, where you don't know what to do with the data. That's how you begin. So images, voice, audio signals, those are the type of data where it fits the need of machine learning. The rest of the use cases that I do or I've seen around is mostly regression, classification, or clustering, which is relatively simple. So in general, anytime we develop any data-driven models, the big issue, number one, is bias. The data that we choose, how we clean the data, how we remove the outliers, biases the model. If the model is biased, the problem is it never behaves like a partial differential equation. So maybe there are a lot of undergrads, but one day you will realize the importance of partial differential equation. That's the only way we can understand the reality. And the beauty of partial differential equations is they are very uniform, they are very generalizable. Unlike that, data-driven models have a lot of biases. It depends on how a person who is developing the model, how he or she decides to clean the data, what type of scaling the person uses. So it's a big challenge. Now, if I go ahead, another big challenge is all these predictions from machine learning have uncertainty. But I have not seen a lot of people quantifying uncertainty. Personally, I also plenty of times completely forget about looking at the uncertainty in the prediction. So that's what we need to focus on. And at the same time, we need to tell how our model can be biased. Bias doesn't just exist in a social environment, it exists in an engineering environment as well. Going ahead, a big challenge that I've seen is there are too many vendors, too many tools, too many techniques, too many different solutions. So what's the right approach? To me, I don't think there's any right approach. Data-driven models are very flexible. These are statistical methods on steroid. So be careful when you use them, and try to do justice with the fact that at the end, these are not partial differential equations, but these are data-driven models. And data changes from place to place, from sensor to sensor, from one engineering environment to the other.
Yeah, very, very good point, especially about the uncertainty and defining that. Like a lot of times we get excited and right into here's what the model is showing without even defining, what are some of the potential, uncertainties with that model. So very, very good point. Thank you for sharing your feedback. Dr. Hedengren, would you like to go next?
Yeah, thanks for that assessment. I completely agree. Uncertainty, being able to understand the strengths and weaknesses of the model, where where they can be applied, and where they have shortcomings. I think that gets into kind of this other area that I've seen as well, which is making the models and their predictions explainable, where we can see not only, here's a prediction and here's the uncertainty, but why did it choose that? And I know there's a lot of effort going into that right now with explainable AI. And I think the other thing that is right in line with that as well is just a big need to educate people on, engineers who maybe have that domain expertise. They are some of the best people to train on machine learning versus somebody trained on machine learning that then tries to gain some domain expertise. Starting with people who have worked careers in this area, and so how do you train them on using some of the tools? Maybe not to even use the tools, but to be able to understand and complement what they're predicting with their domain expertise and guiding features for machine learning, like which things are really the important features that we need to select. How can we reformulate this in a way to fill in missing data with physics-based digital twins or other things that are out there that you can do that with. So again, let me share just one thing here. I've got I teach a lot of people online through the YouTube channel and others, and I have this flow chart for machine learning that I like to use, and we start with the business objective. What is it that we are trying to accomplish with the machine learning, and identify the inputs and outputs. If we have data, then we go on to some of the data cleansing and scaling, splitting it into train, test, and validation sets, and then unsupervised, semi-supervised, or supervised learning for classification or regression or clustering. And then we do a performance assessment and then come back. But this left side, this is, I think, one of the most important, especially with these decades of experience in this area, building simulators, doing regression and other things, that people have developed a very deep expertise on these systems. And so how can we incorporate this physics-based information? And so one way to do that is just to simulate data and then combine that like it's, measurements. That'd be one way of doing it. But I think this whole idea of just understanding and explainability of what comes out and how it got there. And there's two things the algorithms need to do a better job of saying, hey, this is why I'm predicting this. But then also having people with this deep domain knowledge that can step in at different places in this process and be able to apply their domain expertise to improve the quality of what's happening. And the other thing I'd mentioned along with this topic, what are some of the biggest obstacles for this is clear industry benchmarks as well, and data sets and case studies that we can use collectively to develop and refine some of these methods. And there are a couple of pioneers in this area that are really trying to make some of those available. I think Equinor and other companies are releasing large amounts of data for field production. And it's very unusual because many companies consider their data to be that competitive advantage in the industry, and where almost the data is becoming almost as valuable as the reserves in the ground, because it gives them that edge to be able to produce just that much more efficiently, and then in the era of very cost competitive markets, it's that advantage that keeps you in business. So there's a reluctancy to share data and share models and share things. So we've put together this consortium of people in the industry to develop some open source models, test cases, and data. And we did this a couple of years ago and have had a lot of positive feedback about this. How can we collectively sanitize the data sets, but still expose enough of the real issues with the data to really develop some of these things. And there, if you look on places like Kaggle or others that are just great repositories of data sets, you'll find very, very few in the oil and gas industry. So for those that are on today, I guess one of the things I would encourage is make data sets available when possible. It not only benefits you, you can see what others can do with your data, but then it benefits the entire industry as well. So I guess to summarize, then one of the things that I would say is probably the biggest obstacle is explainability and understanding by people that have deep domain expertise and make decisions on this, and then along with that, availability of data.
Thank you so much, Dr. Hedengren. Very valuable feedback. And Dr. Elbanbi, would you like to go next?
All right. I'm at a disadvantage here speaking after the two experts who speak before me. So definitely I agree with all what they said. And let me answer from my perspective the challenges that I have seen with my graduate students when we work on data analytics or machine learning applications in the oil and gas industry are basically three challenges. Number one is data availability. So I get engineers who tell me I want to do an application in drilling, for example. So my first question is, how many wells do you have in your database? And if the answer is 20, 30, 50, I tell him, sorry, find another application. So data availability is one area where we have lots of changes. The second challenge, when we have lots of challenges, the second challenge is the quality of the data. And this is where the domain expertise plays a very important and essential role. The domain expert is the only person probably who can actually clean the data and look for the data that makes sense. Of course, you can use artificial intelligence techniques to help you cleaning the data, but you have to know what you're doing. And this is where domain expertise is a must, actually, to clean your data. Then the third challenge is for an average engineer to learn what to do with machine learning. Usually he or she needs to spend 1 or 2 years going through online lectures, reading a couple of books, attending seminars. So the learning curve takes time to be able to do machine learning. While going through the Q&A part, I've seen a very nice question. The person is asking, regarding the trendy side of artificial intelligence and machine learning, why we see a sort of craze that companies looks for artificial intelligence experts instead of implementing new approaches and ways to enable petroleum engineers to use this powerful tool in the workplace. Actually, we are missing this powerful tool. With my graduate students, we're trying to create a tool that can be easily understood. So we're taking these sophisticated algorithms that are developed by mathematicians, statisticians, and computer scientists, and we're trying to put them in with a nice interface that allows anyone to maybe use the nice interface in half an hour and do something with the machine learning. So in fact, this is a very important area, and I think we should, as an industry, we should make these tools available. One issue, of course, is that the progress in machine learning algorithms and artificial intelligence algorithms is very, very fast. But at least the main ones are known. Let's collect these main ones and put them in an easy to use application that's available to, let's say, petroleum engineers, so they can use that to solve everyday problems if they need to. All right, thank you.
Got it. Thank you. And I'd like to pretty much, I think Dr. Elbanbi alluded to this. Just want to emphasize on the importance of combining the domain experts with the AI experts to for a successful project to occur. We've had, from my personal experience, every time we have, an AI expert, not combine that AI expert with a domain expert, the project usually fails, so it's very important to combine those two together for a successful project. So I just wanted to just allude to that. And this is the only comment that I had for this. So these were the three main questions that I want to talk about today. I think Maryam is with us today. If she'd like to open up the question for all the questions that we've received so far.
Yes, I will start with the first question. What are some examples of the application of AI and machine learning in geosciences?
I think we alluded to that. If anybody would like to touch on that one more time.
All right, I can take that since it is an easy one, and I leave the difficult ones for you guys. So in geosciences, you can predict logs. You can predict permeability. You can do lots of predictions. You can clean seismic data with AI applications. And hopefully in the near future, we will be able to predict properties with AI instead of geostatistics, for example, in between wells. So there are many applications in geoscience that are related to the log data, seismic data, and how we can combine the two of them. Of course, you can also automate the way we pick our tops. This is another application. And the list goes on, and I'm sure the others can add to applications in geoscience.
Would anybody else like to add anything to that?
So detecting of faults is very popular. So in a seismic image, a big focus is where are the faults, because they define some of the paths that you don't want. So machine learning can go through these big 3D volumes of seismic data, terabytes of data, let's say, and they have already learned how to detect the faults, so they can do that process really fast without any human intervention. So that helps a lot. The other thing that I've seen is, for example, on the geomodel side, on the geomodeling, sometimes the models that you work with are really big. They have a lot of cells, let's say 1 million cells. Upscaling is a method of reducing the number of cells in your simulation, but then you can also use some of these neural network technologies for compressing the data. Anytime we use the word neural network, I try to become very cautious, because neural networks, they can fit anything to anything. They are universal function approximators. If you fit X with Y using a neural network, don't be happy, because that's what they are designed to do. So just be careful when you use neural network. If you don't have at least 100,000 samples, my recommendation is there are better methods to use: random forest, or let's say support vector regressors and classifiers. I personally avoid as much neural network as possible in all my oil and gas applications. So hopefully that kind of answers. And I have sent 2 links to 2 of my papers that are open archive, which means anybody can download and read, and that kind of summarizes the entire landscape of petroleum, sequestration, and geothermal, how machine learning is used in all these 3 disciplines. So those of you who are still interested, have a look at those 2 papers. Open access, you can read it without any charges.
Great. Thank you so much.
Our last question is, what are the applications of classification and regression tree techniques in the petroleum industry?
So that question is CART, right? The person is asking about CART, C-A-R-T?
Yes.
Yeah, so I answered that. So CART is a very popular algorithm. It's heavily used in the random forest algorithms. Random forest is a very popular tree-based method. A lot of oil and gas people use it. The beauty of CART algorithm is you don't need data scaling. It's really fast. It takes a little time to learn, but once it learns, your predictions are really, really fast. So it's a very popular technique.
Any other questions?
I think we're running out of time. We still have like 1 minute or so we should conclude the panel.
Okay, great. Well, I'd like to thank everybody again. I appreciate you guys making the time today out of your very busy schedule. Thanks everybody else for listening today. And yeah, Dr. Misra, Dr. Hedengren, and Dr. Elbanbi, they're all very active, I believe, on LinkedIn. So if you have any questions, any questions, please reach out to them and for any questions you might have.
So I saw a question which is very common. One question was, how can I start my journey in data science or data analytics? That's one question that I try to answer in the Q&A. The other question that I'm seeing is how much time will it take to be an expert? So my quick short answer is there's this website, GitHub. So in the GitHub, type machine learning, you'll find a lot of Python-based codes. What I recommend those of you who want to start is get your Python package on your computer, start learning from these GitHub examples, what they have done, try to mimic it on the data sets. And I think in a year, you'll be pretty good in doing basic data analytics. So it's an easy skill to learn. That's my personal opinion.
Sure. Yeah. Thank you.